Need to use the Arduino IDE to modify or install an application or firmware on your ESP board, but don't have any experience with writing or compiling code? Today I'll guide you step by step through the process of installing the Arduino IDE and setting it up to work with your ESP microcontroller. Even if you've never programmed before, don't worry, I'll keep things simple and easy to follow with real-world examples for both the ESP32 and ESP8266. Hi, and welcome to Res and Chem Tech. Now, if you've worked with ESP boards for a while, maybe installing things like WLED or ESP Home or Tasmoda, you may have run across an Arduino application from time to time that you'd like to try out, but it requires compiling and uploading the code using something like the Arduino IDE. Or maybe you just need to make a few code changes like specifying your own Wi-Fi credentials, or maybe changing and using a different GPIO pin for your particular project build. Now, you don't have to be a coder or have an understanding of C++ to be able to do that. Today, I'll show you the easy way to set up the Arduino IDE and configure it for use with ESP boards. I'll also include some examples of making some simple code changes and then show how to compile and upload to both an ESP8266 and an ESP32. As always, links to other sites or URLs will be down in the video description, so you don't have to worry about pausing the video and trying to copy them down. Now, the first step, if you haven't already done so, is to download and install the Arduino IDE. You can find links for the Arduino IDE on the software tab of the official Arduino website. As you can see, there are versions for Windows, Linux, and Mac. I'm using Windows, so I'm going to download the Windows executable file. If you're using Linux or Mac OS, you can find step-by-step instructions here in the documentation. So I will download this. Again, this is free, but if you want to make a donation to support future development, feel free to do so. I'm just going to go ahead and download and save the installer. The Windows installation is pretty much like any other application. Agree to the terms, accept the defaults unless you have a particular need to change them, and go ahead and complete the install. At the very last screen, you have an option to go ahead and run the Arduino IDE. So go ahead and leave that checked. If for some reason you don't or it doesn't launch, go ahead and launch the IDE after installation. Now, if you don't have any previous projects, the IDE will likely open up with a welcome screen or an empty project framework. Now, this is not meant to be a full Arduino IDE tutorial, but really just to show the basic steps on how to get the IDE configured to compile and load code to your ESP board, so that's what I'll be focusing on. There's full documentation on using the IDE on the official Arduino website, again linked to down in the video description. And one of the first things you're going to need to do is select the board and the COM port or communication method you're using to talk to that board. We're going to be using an ESP board, not an Arduino Nano. So I drop this down. Your list is going to look a little bit different. These are some over-the-air things that are broadcasting on my network. We'll go down to select other board and port. So if you browse through or you search this list, odds are you're not going to find your ESP8266 or your ESP32 board in the list here, as this only contains the default built-in versions, which are generally going to be the Arduino boards. So we need to add our ESP32 and ESP8266 boards into our Arduino IDE. Normally that's going to be done through our boards manager, which is our second little icon over here on the left. If we bring that up, here you can see all the available board types that you can install. But if you search, once again, you're not going to find your generic ESP8266 or your ESP32 boards available. To make those available, we need to tell the IDE where to find the definitions and the code for those boards. To do that, we simply come up here to File, Preferences, and you'll see a place down here where we can enter in additional board manager URLs. We need one for the ESP8266 and one for the ESP32, so we can enter them both in here separated by commas, or we can pop this open and simply paste the URLs in one per line. Do notice that the ESP8266 is coming from Arduino, it's a community developed source, but the ESP32 is coming directly from Espressif. So we'll go ahead and save those. Now if we go back to our board manager, we can simply search for ESP, and you're going to see there's our ESP32 by Espressif and our ESP8266 boards. Now, I already have them installed. If you don't, there'll be an install button right here. You can click that to install both of them. You're only going to be using ESP32. You don't have to install the ESP8266 or vice versa, but it doesn't hurt to install both of them and have all the boards available. If you don't see these, you might try shutting down and restarting the IDE to see if they show up. If they still don't show up, go back and double check those URLs carefully. Once we have those installed, we now have the ability to come up here, select another board and port, and we can simply search for something like ESP32, and we can see all the different types of ESP32 boards that are available for us to select for our project. In a similar manner, we can search for ESP8266, and once again see all the different types of ESP30 or ESP8266 boards that are available. We just need to select the one that matches our build. And with that done, our environment is set up, so we're ready to try a couple of examples of loading some code to an ESP8266 and an ESP32. For my ESP8266 example, I'm going to use a Wemos D1 Mini, and for my ESP32, I'm going to use an ESP32 Mini, but of course you can use other full-size boards like a Node MCU or even an ESP32C3 or S2. As long as the board is defined in Arduino, we can use it here. The only other thing I'm going to need is a micro USB data cable to connect this to a USB port on my PC for doing the initial flash. Now we've got the Arduino IDE set up, but we need some source code that we can modify, compile, and upload. Back over in the IDE, I've gone ahead and I've connected my ESP8266 or my Wemos D1 Mini to the USB port on the computer. Now I need to come in here and select the proper board and the proper COM port. So we'll drop that down, select another board and port. Over here for the boards, let's just do a search for Wemos, and there's our Wemos D1, R2, and Mini. So we'll select that for our board. Now I need to select the proper COM port. You may see more than one. If you're unsure which COM port it is, simply unplug it from the computer. You notice a COM port disappears, plug it back in, and a COM port will reappear. So we'll make sure we select the D1 Mini and COM4 and go ahead and say OK. Now we're all set, but we have nothing to load here. Before going out and trying to modify and upload firmware, you can do a quick check if you want. There are numerous examples available under File, Examples. You see all kind of examples for the Wemos D1 Mini, but we're just going to come up here to Basics and load something called Blink. It's going to load a new window for us. We'll let that load up. All this is going to do is blink the onboard LED here on our D1 Mini. We don't need to make any changes, it's just a very simple test. So the first thing we'll do is we're going to verify this code to make sure we have everything installed and set up properly. So we'll click Verify, and down here you see it's going to compile our sketch, check for any errors or anything that might be missing. Okay, that completed without any big issue here. So at this point, we can go ahead and click the Upload button. Once again, it's going to compile the sketch. It only takes a second, and now you see it's connecting, and it is writing to the D1 Mini. As soon as it's done, the board is going to reboot, and you can see on our board now that the LED is blinking once per second. That's exactly what we would expect, and that means everything is configured. We're able to upload code to the D1 Mini. We're probably going to want to load something a little bit more than just these example sketches. So now let's take a look at an example of some code we can get from a GitHub repo, how we can slightly modify that, compile it, and upload it to the D1 Mini. For this example, I've selected a project that uses a D1 Mini and some WS2812B LEDs to create a parking assistant for your garage that always assures you park in the same spot. Now, if we take a look at the documentation over here, we'll see that while it works with most ESP8266 boards, it does recommend a D1 Mini, which is what I'm using. So we'll go back to the code. If we check the latest releases, we will see that this particular project does make compiled binary files available. That means we could just download that and use a desktop utility like Node MCU Pi Flasher or ESP Home Flasher and just flash this right onto our D1 Mini without the need to recompile. But we also can't make any changes to the code in the compiled version. What if we need to make a small change to the code? If you're familiar with GitHub, you can always clone or fork the entire repository, but that isn't necessary, and if you're just a beginner, there are a couple of very easy ways to copy the repo. The quickest and the easiest is to click this code button and select the option to download the zip. You can save this somewhere locally on your machine. If we then open this downloaded zip file, we'll see we have the same folder structures as we have in the repo itself, including all of the individual files. But we really don't need things like examples or the 3D printed STL files to be able to modify the source code. What we really need is in our source folder, and that is the sketch right there. Now we could just extract the source sketch file from here, but let's go back to the repository and look in the source folder. Back in our repo, we're going to go into this source folder and we'll see we have some information right here. Most well-developed and supported repositories will have documentation either on the main page, maybe in a wiki, or in a README file somewhere that will tell you what you need to download and modify the source code. In this particular case, it's saying the only thing that we need is this parkingassistant.ini file. So instead of downloading the entire zip of all those files, we'll select this file, then just come over here to download the raw file, select that, and you can see now we're just going to download the parkingassistant.ini sketch file. But where do we save that file? On Windows, if you did a default installation, you will find an Arduino folder underneath your Documents folder. That was created for you automatically, and this is where all of your sketches will live. Now you can see I've already got a bunch of them here. Odds are yours are going to be empty if you're just starting out. But you may also see a libraries folder. This is also where libraries will get installed, but we'll talk about libraries in just a second. Now, the standard best practices say that your folder should have the same name as the primary sketch file, or in this case, the INO file. So I'm going to create a new folder, and I know the name of my INO was parking_assistant, so that's why I'm going to name my folder. So now I have the folder created. Now back over in the repo, I'm going to click this download raw file. And this time I'm going to go to my documents, my Arduino, find my new parking assistant folder, and save the file there. That's really everything that we need for this particular project. We've got the source code. We're now ready to open that up and make our modifications in the Arduino IDE. I still have the Blink sketch running on the D1 Mini over here. But now what we want to do is we want to take the parking assistant application, modify it, compile it, and upload it to the same D1 Mini. To do that, we just need to come up here, browse to our parking assistant folder, and open up the sketch in the IDE. Now, before we make any changes, a couple of things we want to do. First, make sure you still have the right board and the right COM port connected up here. We do. Then you're probably going to want to go ahead and make sure that you can verify or compile this code as is before you make any changes. Part of the reason you want to do that is to make sure that you have all the libraries available. Most applications will use external libraries, and those libraries must be available or installed on your machine before you can compile the code. Just to give you an example, because I happen to know I have all these libraries already installed, I'm just going to stick a dummy library in here that I know doesn't exist, and I'm going to try to verify the code. So it's going to go out, it's going to try to compile, it's going to try to pull in the code from all those libraries, and you can see that I'm missing .h, which I just added. No such file or directory exists. So in that case, what I want to do is I want to add these missing libraries. This code's nice because everything is documented, but let's say, for example, I was missing the Arduino OTA library. I can simply come over to my libraries, do a quick search for that library name, and there it is, and I can simply click install to add it to my environment so that the code will compile. I'm going to go ahead and remove this fictional library and go ahead and try to verify the code, but again, before I make any changes. Okay, you can see I successfully compiled, so now I know I can compile this code before I make any of my changes. So at this point, I'm ready to make any modifications that I need or want for my particular project. If you recall, the one change I wanted to make was changing the GPIO pin that I was using for my LED strip. Instead of GPIO 12, I want to use GPIO 2. So I'm going to make that change. I'm going to go ahead and do a quick verify just to make sure that no changes that I made broke anything. Again, generally a small change like that isn't going to break anything, but it's always a good idea to do anyway. And you see it compiles much quicker because it was a small change. And now we're good to go and ready to upload it to our D1 Mini. You can see our D1 Mini is still running the Blink. One last time, I want to double check, make sure I've got the correct board and the correct COM port, and I do. This time we're just going to click upload. Once again, it's going to verify and recompile that sketch one final time before it starts to upload to the D1 Mini. We should be able to see that the LED should stop blinking. Okay, now it's flashing slightly as it receives data, but now we're actually writing this new code to the D1 Mini. Okay, and in this particular case, we see the LED light came on and stayed solid, which is what this particular code does. So we now have the parking assistant code uploaded onto this D1 Mini. We're ready to go use it in our project. For our next example, we're going to take a look at a different but fairly common scenario. For that, I'm going to use this repository for the code for a DIY amplifier, but that's really beside the point. Do note that this does say that it is an ESP32 based project. So in this particular case, we are going to be using an ESP32 instead of the ESP8266. We'll talk about that in the IDE. But what you will often see a lot of times in sample code is something that looks like this, where it's going to connect to Wi-Fi, but it needs your Wi-Fi SSID and password. And a lot of times you'll see that just written right here in the code, which means you have to modify this code, compile, and upload it to your board. In addition, there's one other thing about this repo that is different from the first one we looked at. If we take a look in the source code folder, we'll see in this case we have multiple files. We don't just have a single source code file, we've got a couple of these H files. If we look at the documentation, it says that those two files are also needed, and the credentials.h file must be edited with your Wi-Fi and MQTT information. So in this case, instead of one INO file, we have an INO file plus two header or H files that we need to include. If we take a look inside the credentials file, we'll see that this is where we set up all of our information for things like Wi-Fi and our MQTT broker. And if we look inside the settings file, we'll see this is where we define things like the GPIO pins and some other options that we may wish to change for our particular build. And we need all three files. You can download each file individually like I showed before, or you can download the zip file of the entire repository, open it up, go to the source code folder, and extract those three files. But what you want to end up with is just like before. I've got an acrylic_amp folder, which matches the main INO file, and I also have the credentials and the settings file available in that same folder. Back over here in the Arduino IDE, I've once again loaded up that sample Blink sketch, but notice up here it still is indicating my Wemos D1 Mini. So the first thing I need to do is I need to select the proper board and once again verify the COM port. So we'll go to select other board. Right now I'm just showing the serial COM3 port. So I'm going to go ahead and plug in the ESP32, and we can see that COM port 5 pops up. So I'm going to select that. Now for my boards, I'm going to again search for Wemos, and there's my Wemos D1 Mini for my ESP32. So I'll select that board and say OK. Now we've got the proper board selected. If you want, you can go ahead and compile and upload this to the ESP32 just to verify that it's working. So once again, you can see that the LED is now blinking. That means we've got the board configured correctly and it is communicating to the IDE. At this point, we're ready to open up that other sketch that we need to modify. And to do that, we're simply going to go to File, Open. Once again, I'll browse to my Acrylic Amp folder, and there is my INO sketch file. I will go ahead and load that up. And a couple of things to notice. Notice it already has tabs in here for those extra two files for my settings and credentials. Since they were in the same folder, they got opened up as part of this project. So now I can simply jump over to this credentials.h file and replace all of these values with my actual network information. Okay, once I've done that, I can also go over to the settings file if I need to change anything in terms of the GPIO pins or any of the other information here based on either the inline comments or the instructions in the repository itself. When that's all done, I can come back to the main sketch file. If there's anything in here that I need to change, so for example, this actually will work with various IR remotes, and if I need to change the codes, I can change those here. Again, it's documented. And naturally, I will need to have all of these libraries installed. But assuming that I do, I'm once again going to double check that I've got the right board and the right COM port, and I'm going to go ahead and verify this sketch. And you can see that I've got an error here in the compilation, and this actually has to do with one of these libraries. It's actually the IR remote library. It doesn't work with the new Core 3.x for the ESP32. It only works with the Core 2. So I would have to make a choice here about whether using a different library, seeing if there's an update for this library, or dropping back to the ESP2 core, which I really don't want to do. So I would probably look for a different IR remote library. Okay, a quick check of the GitHub repo, and I found that there is an update for this IR remote library that does include support for the Core 3. So I'm simply going to update this library, and that will take just a second. That's already been updated. So now I can try to verify my code once again and see if that takes care of my error message. Okay, this time that took care of the problem. It compiled without any issue. So now I've got everything set and I'm ready to upload to my ESP32. Once again, I'm just going to check, make sure I've got the right board and the right COM port. I do. I'm going to go ahead and click the upload button. Once again, it's going to recompile the sketch and this time actually upload it to the ESP32. Okay, we're actually uploading it to the board now. You'll notice that the LED quit blinking because the blink sketch is no longer there. And there we go. Now I've got the new code on here. It is configured to connect to my Wi-Fi, and it will be ready to now install it in the project. This does serve as an example of sometimes you have to fidget around with some of these libraries, especially if there have been some code changes or some new versions released, and the original developer might not have kept his version up to date. So now, just by modifying something as simple as the Wi-Fi credentials or maybe a GPIO pin, we've successfully installed the parking assistant firmware onto an ESP8266 and the DIY amp firmware onto an ESP32. All of this without writing any of our own C++ code. And there you have it. You now successfully have the Arduino IDE set up to work with your ESP8266 or your ESP32. Now you can go out there and maybe try some of those cool projects you've seen on GitHub or on other websites, but had avoided in the past because it required compiling and uploading with the Arduino IDE. Or maybe you'll pick up enough Arduino code along the way that eventually you'll be able to start creating your own amazing projects. I have a number of Arduino projects out there available in GitHub, and I'm always happy to answer any questions that you might have about how something works. So experiment, try new things, and don't be afraid to make mistakes. The Arduino and ESP communities are full of people that are willing to help, myself included. Until next time, I'd like to say thank you for watching, and I hope to see you soon.